So today, actually, I have two major parts. First one, I would like to update the energy consuming status in the semiconductor industries, and the second thing is that how I can the second thing is how I can introduce the energy saving solution in the heating system in the semiconducting process. Yeah, actually this data is exactly same as which T-Ball presented. So he saved my time. One thing clear is that to go to the net zero 2050, we are going to use more electricity, and then we should prepare more renewable energy. That's the point, and T-Ball actually explained more than enough data. So I look into Taiwan. How is Taiwan doing? Actually, we have two things. In the legal-wise, Taiwan recently announced the Climate Changes Response Act in February, and this is, I think, is the first legal framework in Taiwan to control the energy. And then this one is going to definitely impact a lot in the semiconductor industry in Taiwan. And then in this supply side, I can see Taiwan is efforting a lot to build more wind energy. And so Taiwan is making a lot of the wind turbine in the inshore and offshore. And in year 2030, Taiwan is going to have around 4.2 gigawatt of their wind energy supply capacity. Then wind energy capacity. And then I believe that in the future we are going to live in the renewable economy circumstance. So we're gonna use more clean energy, and then a lot of EVs is gonna be running in the street, and then we're gonna have more solar power. And then to build this renewable economy, we need two things. First one is semiconductor. The second is the battery to keep the renewable energy, because renewable energy cannot be on whenever we want. So it is very sure semiconductor demand is continuously going up. For example, very simple example, when we use the fossil-free car, we need around 300 pieces of chips. But when we use the electric vehicles, we need around 1,000 pieces of semiconductor. But when we go to the self-driving, we need 2,000 pieces of chip. So we need more and more semiconductor. That's very true. So this data is very popular. This right side is very popular. Current semiconductor industry is around 600 billion revenue. But in year 2030, it's gonna go to reaching to more than $1,000 billion. And it is very sure it's gonna make it come true. Because when we see the last 5 years investment announcement, it is more than to achieve this revenue. It is true. However, semiconductor industry has the paradox. What's the paradox? It is very sure we need a lot of semiconductor to make the renewable economy circumstance, but semiconductor manufacturing process is the dinosaur to consuming a lot of electricity and energy. This is a very good example. This is South Korea energy consumption. South Korea actually annually consuming around 580 terawatt of the energy, electricity. Among them, 3% is consumed by Samsung Electronics. Taiwan is more serious. In my study, Taiwan is consuming around 270 and 280 terawatt a year, but TSMC is consuming 6% of the electricity. But furthermore, it's getting worse. We need higher technologies, and EUV equipment is going to be adopted more and more, especially for the foundry. And when we guess we have 40 pieces of the EUV equipment, we can simply calculate based on ASML's energy estimation calculation. We can get around 0.5 terawatt is going to be extra used. This is really paradox in the semiconductor industry. We need a semiconductor, but semiconductor industry is the monster consuming a lot of electricity. Here is the data. So we studied about the carbon footprint. And when you see this, all the electric semiconductor companies is announcing this data. Compared with the scope 1, basically semiconductor companies has a more carbon emission in their scope 2 actually. So scope 1 is comparatively lesser than scope 2. So we studied further. Actually, I could see the McKinsey's data, and I realized that this data is really right. When I see the McKinsey's data just now, they are saying that 45% energy was consumed by the facilities in the scope 2, and I can find a very similar data from National Taipei University of Technology. They had this kind of data. They study each category of the manufacturing facilities, how many percentage of the energy is consuming. And then heating system is consuming around 22%. So next page, I want to go to the heating system. I think everybody knows here, heating systems, purpose is very simple. We want to keep this certain temperature for the chamber and pipe to sustain and to keep the certain temperature to maintaining smoothly the chemicals flow. And then this is the basic process which Mr. Kerr even knows very well. And what we didn't look into carefully in the industry is that we are studying a lot of here, we are studying a lot about here and vacuum pump, but we didn't look into carefully about the pipe in the middle of the equipment, major equipment. So actually, all this pipe is covered by the heating jacket. Heating jacket is simply saying that it's kind of electric blankets, which we are using in the winter time. So this is like that. Yes, this is the picture of the heating jacket. So normally these pipes was wrapped by those kind of Teflon fabrics. However, this Teflon fabrics problem is that this energy efficiency is not great. So the thermal conductivity is really bad. So we thought about how we can improve this. Even Applied Material, Mr. Kerr just mentioned that there is just many of the segments in the facilities where we can save the energy. But he said that even on utilizing timing, we cannot idling the pipe because we should always keep the pipe warm and certain temperature. So yes, that's true. However, we think about this kind of design. We insert, instead of this outside of wrapping, we insert the coils inside the pipe, and we would like to keep the certain temperature always. And then, honestly speaking, we developed this more than 10 years ago. At that time, we always say to the customer, ours never have a blocking in the pipe because we can keep the very sustainable temperature always. And compared with the heating jacket is the one keeping the temperature from the outside to inside the pipe, but we do directly inside. That's why efficiency-wise, it cannot be compared to each other. And then we can very fast ramping up the temperature inside the pipe. So actually this technology was not well known in the industry. Actually, we only sell one company in South Korea, SK Hynix. Actually, we sold around 8 years. So, in the SK Hynix, there's a factory which has a wafer capacity is 150K, and we could understand that we could have a data. We could save 66% of the energy compared with the heating jacket. And I just mentioned that total heating systems consuming energy portion is around 22% of total semiconducting process. And then the exact figure is that 33 gigawatt. And then if we convert to the cost, South Korea actually one of the cheapest country in energy cost is one of the cheapest, only 80 cents. So we calculate based on 80 cents, and then we can save around 3.1 million US dollars. But the most important actually is not the money. The most important is the carbon reduction. We could get around almost 60,000 tons of carbon emission. We can reduce around 16,000 of carbon emission. That's actually great. And even if we convert this one as a carbon certificate cost, we can save around $4.3 million per year based on 150K pieces of wafer input. So this is actually SK Hynix press release, which they have done in March. And they actually showed a lot of their net zero effort in the public, what they are doing. And as only one, actually they introduced only one example as a very successful co-working with the partners. That's the inner heater. So, think it over. I just said that based on 150K pieces of the wafer input capacity, we could annually reduce around 33 gigawatts. I thought about very mathematically, I calculate that. Taiwan has around 4.1 million pieces of the wafer input annually. And when we just calculate mathematically, we can save 0.9 terawatt of their energy consumption. So how big is the 0.9 terawatt? Taiwan in 2022, they got the power from the wind energy, wind power, 3.5 terawatt only. And then if we just assume we change all the heating jacket to inner heater in Taiwan, we can save almost 26% of the wind energy. That's actually a huge portion. And then even if you calculate to the money, it's gonna be very huge. So my conclusion is like that. Semiconductor industry is really innovative. Our product and our equipment, we always see a lot of innovation every year and every moment. However, we don't look into carefully about the facilities actually. And then from the facilities, there is something we can save those things. And then I have another thing, whenever I attend a sustainability summit and forum in the other countries, I can listen there. You guys always, speakers always say that net zero 2050 cannot be acquired by single company's effort. Let's do it together. Let's join, let's do it together. Yes, that's true. But I think that very interesting is that our facility relative, I don't why we have to use the same technology which we have been using for the last 30 years. So I want to say to you guys, let's be a bit brave to adapting the new technology, and let's open more door for the new technology. Let's give the more chance to a small company like us. And actually, we have the responsibility to hand over the very clean earth and clean circumstance to our next generation. Actually, I broke my son today to learn about it. So I think that we should be together always. And then I hope we should be a bit brave to open the door. Yeah. Thank you so much.
Thank you, Mappy. And I understand you have an exhibition booth here today?
Yes, yes, we have an exhibition booth in the hall 1, K3264. Actually, singing is believing. We brought our pipe sample. So one is the heating jacket, the other one is ours. So we turn on from this morning, so you can see how much of energy gap is happening in there. Singing is believing. Please come to our booth.
Yeah, I'm
Thanks.
doing some promotion for your
Thank
company.
you so much. Thank you very much.
So yeah, seeing is believing. I think you could pay a visit to all our sponsors here if they have a booth here. And thank you very much for your presentation
Thank you very
today.
much.
So our last but not least speaker for the day is Mr. Yoshihiko